Good day to all. Today we can discuss about the topic of binary and ternary diagram in material science, which is involved in alloy phase diagram. In previous video we discussed about unary diagram, how the unary diagram available and how can we study the unary diagram. Likewise we discussed. In unary diagram we discussed about pressure and temperature axis diagram only. Today we have discussed about third axis, which is composition. Likewise we may discuss with this topic. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering, K. Ramakrishnan College of Technology, Tiruchirappalli. In that, what is binary diagram? In pressure temperature diagram, it is necessary to add composition axis. Alloy composition we can add with that third axis so that the plot is three-dimensional. Maximum majority of metallurgical problems or metallurgical scientists considered fixed pressure of a single atmosphere. So the graph is converted to temperature and composition diagram in binary diagram concepts. Already we know about equilibrium. What all the equilibriums are available with the phase diagrams, which are stable, metastable and unstable structures are available. Here what is stable? Object is in lowest energy state is called as stable region, and then metastable equilibrium means additional energy that introduced before getting stable condition, which is known as metastable. And we are discussed about unstable also. Unstable means no need of additional energy before entering into stable or metastable conditions. These are all the equilibrium conditions also we studied with the unary diagram. Here in binary diagram, what is the stable equilibrium? In binary diagram we should aware about the stable equilibrium, so that stable equilibrium of binary system can be expressed with the phase rule. When the effect of pressure is constant, the phase rule become small f is equal to small c minus small p plus 1. Here the small f is describes about number of independent variable, which is degrees of freedom, and then small c means number of component and small p is number of stable phases in the system. Here in binary diagram we can study this equation with the following table conditions. Number of components may be 2, number of phases is 3, then degrees of freedom is 0, means the system equilibrium condition is invariant. But the number of components 2 and the number of phases also 2. Here solid liquid or solid gaseous, which are phases. So number of phases is 2, degrees of freedom is 1, means which equilibrium condition is univariant. And then number of components 2 and the number of phase, which may be in solid or it may be in liquid or it may be in gaseous. Likewise any one phase it follows means that equilibrium condition is called as bivariant. And then which is the diagram involved for describes about miscible solids. What is meant by miscible solid? Many systems are composed of components having the same crystal structure. Crystal structure means FCC, BCC, likewise lot of crystal structure available. What are the crystal structure? Basic I did explain with our previous presentation, so that you should aware about what is crystal structure. How can we explain that? Here, and the components of some of these systems are completely miscible when completely soluble in each other in the solid form, thus forming a continuous solid solution when that this occurs in a binary system. The phase diagram usually has the general appearance of this diagram. Okay, the diagram consists of two single phase fields separated by a two phase field. The boundary between the liquid the boundary excuse me the boundary between the liquid field and the two phase field, you can see with this diagram, is called the liquidus. That between two phase field and the solid field is the solidus. Here you can see solidus and the liquidus region. Here what is meant by solidus? Solidus means that between the two phases field and the solid field is the solidus in general. So liquidus is the locus of points in the phase diagram representing the temperature at which alloys of the various compositions of the system begin to freeze on cooling or finish melting on heating. A solidus is the locus of points representing the temperatures at which the various alloys finish freezing or cooling or begin melting or heating. The phases in equilibrium across the two phases field as shown in figure. Here the liquidous and the solid solutions are called as conjugate phases. So now the liquidous and the solidus phases are called as conjugate phases. So now what is meant by miscible solids we can understand with this diagram, and then we can move for another diagram which is eutectic reactions. What is eutectic reaction? In this three-phase reactions are occurred. Three-phase reactions are occurred that takes place at the invariant point E. Here you see the point E, where a liquid phase freezes into a mixture of two solid phases is called a eutectic reaction. Here what is eutectic reaction? You first consider the invariant point which is E. Here the liquidous phase freezes into a mixture of two solid phase is called a eutectic reaction. Okay, eutectic reaction, eutectic means it is a Greek word, it is easily melted. The alloy that corresponds to the eutectic composition is called a eutectic alloy. The alloy having a composition to the left of the eutectic point is called a hypoeutectic alloy. So here you see the left side of the eutectic point is called a hypoeutectic alloy. What about the right side? In right side we can called as hypereutectic alloy, meaning greater than and lesser than. Lesser than is called as hypoeutectic and higher than, which implies for hypereutectic alloy. Now we can study the miscible solids diagram with the binary explanation, and then eutectic reactions we can understand. Then next alloy phase diagram is ternary diagrams. What is meant by ternary diagram? What is meant by ternary diagram? When a third component is added to a binary system. Here we can add a third component into a alloy phase diagram, and also we can introduce the third component into a binary system. We can get the ternary diagram. It illustrating about equilibrium conditions in two dimensions becomes more complicated. One option is available, that is to add a third composition dimension to the base, forming a solid diagram having binary diagrams at 6 vertical slides. So we can study this diagram with the vertical slides. This can be represented as a modified isometric projection, such as this diagram. Here boundaries of single phase fields, which are liquidus, solidus and solvers lines in the binary diagram, become surfaces. Single and two phase areas are become volumes. Three phase lines become volumes, and four phase points here not shown because we consider about only three phases, which can be exist as an invariant plane. The composition of a binary eutectic liquid, which is a point in a two component system, becomes a line in a ternary diagram. So these are all the diagrams. In previous video we discussed about what is unary diagram, and the material science has its own binary diagram and ternary diagram, which are the basic introduction about what is meant by binary diagram, what is meant by ternary diagram. Now we can get simple introduction about those things. Thank you all.